Now this topic is about polynomials, and polynomials just refers to expressions with many different terms. Now these terms may have x terms, which will also have x to the power of different degrees, like x cubed or x squared, x to the power of 5, and so on. Now the first concept is identities. For identities, we have two different methods of solving questions. Our first method is when we are solving usual questions. So the question will be something like they'll give a polynomial and then they'll equate it to the same polynomial just represented in a different way with unknowns that we need to solve for. So our first step is always doing comparisons between the x term with the highest power. Now the x term with the highest power in this case is x cubed. So we'll just be focused on the x cubed terms for in this equation. Now the comparison always occurs between the left hand side and the right hand side of the equation. So on the left hand side, our x cubed term is 2x cubed over here. And on the right hand side, we'll have to manually expand to find our x cubed term. However, you do not need to expand the entire polynomial, like all the brackets. You just need to expand enough so that you get your x cubed term. Now how do you get x cubed? You just x times x times x, right? So now we are just finding all our x terms in all brackets. So ax, 2x, and x. Now once we expand all these three terms, we'll eventually end up with 2ax cubed. So comparing left hand side and right hand side, you equate 2x cubed equals to 2ax cubed. And then from here, you'll get 2 equals to 2a, because you're just comparing the coefficients. By that I mean this 2 and this 2a. So the coefficients of your x cubed term. Now once you have 2 equals to 2a, obviously you can find a, which is just 1. So now you have your a term. Then we move on to finding our c term, because if you notice it's a standalone term, so we can find it quite easily. Now looking at step 2, we can sub in suitable values of x to make 0. Now making 0 just refers to making this part of the equation 0. Then you'll be left with c. So how do you make it 0? We can look at these brackets. We can either sub x equals to 3 or x equals to 2. Because for example, let's say we sub x equals to 2. If we sub x equals to 2, if we look at this bracket, it will become 2 minus 2, which is equals to 0. Now that this bracket equals to 0, everything attached to it, so everything multiplied to it, will also be 0. Because 0 times anything equals to 0. So once it's all 0, then we can just ignore its entire part, because it will just disappear. That's why leaving us with c. And then of course, when you sub x equals to 2 on the right hand side, you also have to sub it in to your left hand side. So you sub x equals to 2, calculate the left hand side, and then right hand side is just equals to c. So now you have your c equals to 29. Okay, now moving on to the last step, we will get an easy value of x. We'll sub in an easy value of x to find our last unknown b. Now an easy value of x just means you want a number that is easy to handle. So in this case, it will most of the times be 0. So you sub x equals to 0, both on the left hand side and the right hand side. And once you sub x equals to 0, you end up with an equation like this. And then you can solve your b, which will be equals to minus 4. Therefore, you have these three values. You have your unknowns found. A equals to 1, b equals to minus 4, and c equals to 29. Okay, now type 2 questions is when you realize that it's not helpful at all to sub values of x to find your unknowns. Okay, if we focus on this example given, let's say we use the type 1 way of solving this example. So if we use type 1 way, sub x equals to 7, then this whole part will be equals to 0. That's making 0, right? However, we can see that there is still a minus b left on the right hand side, which is two unknowns. Once you have two unknowns, you can't really do anything and you will kind of get stuck because you cannot find a, you also cannot find b. So what can we do now? Usually when it's not helpful to sub in values of x, we'll just completely expand whatever's given to us on the right hand side. So this method just involves the full expansion of the right hand side. So it gives us the individual terms of each x term or each term in the polynomial. Then we can do a direct comparison between the coefficients of each x term or each term in the polynomial to solve for unknowns. Okay, so the first step is to expand the whole right hand side, which will leave us with this equation. So then we can equate left hand side equals to right hand side, which is here. And then we can start doing our direct comparison of coefficients. Now if we notice, the terms that we are more interested in will be the ones with obviously our unknowns in it. So on the left hand side, it will be our x squared term, 2a plus 1. On the right hand side, it will be minus 8. So focusing on the x squared terms, we'll equate left hand side equals to right hand side. 2a plus 1 equals to minus 8. And then solving for our a, can get a equals to minus 9 over 2. And then we still have one more unknown, b. So how do we find b? We can compare our constants. So constants is just any term in your polynomial that is not attached to an x. So on your left hand side, you have 6. On the right hand side, you have 49 plus a minus b. So once again, equating left hand side to right hand side, you will form your equation 49 plus a minus b equals to 6. Okay, for here, you already know your a term, right? A equals to minus 9 over 2. So you can sub a equals to negative 9 over 2 in this equation, and then you solve for b, and then you can get 38 and 38 and a half. So now you have your unknowns found. A equals to negative 9 over 2 and b equals to 38 and a half.